Hey, have you ever really thought about the words heat and temperature? You've probably used them to mean the same thing your whole life. I mean, we all have, right? But what if I told you they're actually two completely different concepts? Well, today we're going to crack that common puzzle once and for all. Okay, let's just jump right in with a brain teaser. Imagine you've got a small, steaming hot cup of tea. And over here, you've got an entire bathtub full of just warm water. Now, here's the question. Could that tiny cup of tea actually hold more heat than the entire bathtub? It just feels wrong, doesn't it? But stick with me, because by the end of this, you'll know the answer and you'll get exactly why it works the way it does. So, to solve our puzzle, we have to start with the basics. We've got to figure out what temperature really is. And believe me, it's way more interesting than just a number on your phone's weather app. It all comes down to invisible microscopic motion. Okay, so here's the scientific deal. Everything, and I mean everything, is made of tiny particles, atoms and molecules that are constantly moving. They're jiggling, they're vibrating, they're bouncing all over the place. And temperature? Well, that's just a way of measuring the average speed of all that microscopic chaos. The faster those little particles are shaking around, the higher the temperature. So, if you're gonna remember just one thing about temperature, let it be this word: average. That's the key. Temperature doesn't care about the one super fast particle in the group, and it doesn't care how many particles there are. It's just the average speed of the whole team. It's a team statistic. All right, so if temperature is really just about how fast tiny things are shaking, how in the world do we actually measure that? I mean, we can't see them. Well, that's where some very familiar tools come into play. We use a pretty simple tool. You've definitely seen it: a thermometer. And the number it gives us is usually in degrees Celsius. So when you stick a thermometer in that hot tea and it reads, say, 90 degrees Celsius, what it's really telling you is that the particles inside that tea have a very, very high average speed. It's a speedometer for molecules. And this right here, this brings us to the big mix-up, the reason we get so confused. We use the word hot to describe something with a high temperature, but we also use it when we're talking about heat. But in science, those are two very different ideas. And get this. Something having a high temperature doesn't always mean it has more heat. So let's lay it out side by side. Temperature, like we said, is all about the average speed of the particles. Think of it as how energetic each particle is on average. Heat, on the other hand, is about the total amount of energy from all that motion combined. They're definitely related, but they are not the same thing. Not at all. Okay, you've got the tools now. You know the crucial difference. So let's go back to our big question: the tiny, hot cup of tea versus the huge, warm bathtub. Now that you know temperature is the average and heat is the total, which one can have more heat? And the answer is yes, the bathtub can absolutely have more heat. I know, it feels completely backward, but the science here is solid as a rock. The cooler bathtub can be packing way more total heat energy than that steaming little cup. So how is that even possible? Well, think about it. The particles in the tea are moving incredibly fast, on average. That's why it has a high temperature. But, and this is the big but, the bathtub has trillions upon trillions more water particles in it. It's a numbers game. Even though each particle in the tub is moving slower, the sheer mind-boggling quantity of them means their total combined energy, the heat, is actually greater. If you're still trying to wrap your head around it, think of it like this. Temperature is like the average speed of a runner on a team. Heat is like the total distance the entire team runs. You could have one Olympic sprinter who is incredibly fast. That's your hot tea. But a whole marathon full of thousands of joggers, even though they're slower, will cover way, way more ground in total. That's your bathtub. Temperature is the average, heat is the total. So there you have it. The puzzle is solved. Temperature is the average jiggle, and heat is the total energy of all those jiggles combined. But this whole idea leaves us with one last, kind of mind-bending question to think about. If temperature is just the motion of particles, what would happen if you could make all those particles stop moving completely? What would you even call that ultimate state of stillness? Something to chew on.